So I don't know what you're going to do. But let us complete with the gas flow. I just follow the instructions. So I'll continue with gas flows. So as we wait for the rest, that is the topic. I hope you can see the topic. So actually, I didn't use the summarized notes, but I chose these ones, but we'll summarize them with you. So we'll be, this one will help us understand deeper than my summarized notes. I thought it was very sketchy and it will take some time to understand. But when you see the full note, I thought it would be better. But we'll summarize them. We cannot, of course, read every part of it. But it is good because it gives us some very good scenarios uh, that will better explain the gas law itself. So I don't know. Nobody sent me the graphs. I gave you a question on graphs. So I've not yet received the graph. So I don't know. I don't know yet how to handle that one. I don't know if people understood or not. But
Teacher,
hopefully,
I'll send mine after we finish today.
okay, yeah. So kama bado tujamaliza, it is still okay. You still have time. So I don't think there is a problem. So we can continue. I think we can start. As others come in, they'll just join us. So we have what we call gas laws. So gas laws actually is something that we already introduced in Form 1. It is something that we introduced in Form 1. So in Form 1, we were saying when you talk about matter, we say matter as is made up of three states. So number one was liquids, gases, and solids. We have, of course, plasma. But plasma, we do not normally mention it a lot of time. But anytime you ask about four states of matter, you are supposed to say there are four: solids, gases, liquids, and that plasma. Now, when we talk about liquids and gases, we normally categorize them under what we call fluids. So gas laws actually is something that affects the fluids, which is liquids and gases, but mostly gases. We'll be seeing that one as we continue. So it affects mainly fluids. So in Form 1, we were talking about the states of matter. In the states of matter, we want to call the kinetic theory of matter, where we learned about small particles making up the bigger. If I wanted, for example, let me just use examples that we are not allowed to use. For example, human beings. So a person is made up of small particles. We are solids, but we are made up of small particles that have been brought together. So we have the head, we have the hands. Yeah, I normally use that one, but it is not allowed to use. You are not supposed to use human beings, so you're supposed to use something else because we say like this: uh, the value of life is on a different level, so we don't normally. So anyway, so liquids made up of so particular that occupy space and mass. When you talk about mass, you're talking about volume, you're talking about density because you can give a relationship. I think I mentioned that one previously. I think we did a question where we say that density is equal to mass over volume. So when you give a volume, most probably something that has volume will have mass and it will have density. So and we say these things now, it normally we have what we call what is the name leaving me? A Brownian motion. Yes, Brownian motion. So Brownian motion means a random movement of particles. So the particles are moving randomly. And when they do that and they collide with the walls, those ones, if somebody is doing physics, I think they can understand this one. They'll give this one a different way. They will the definition will be different. So when the Brownian motion, random movement touches the walls of this of the vessel. Let me say the vessel that is in or the tube or the container in which that gas is in or in which that liquid is. And when that one happens now, it will the walls will experience what we call pressure, and that one now is gas pressure. So when particles move randomly in a gonga gonga ukuta, it develops what we call the pressure, which is now what you're going to do. So pressure is no the loss. The pressure is one of the factors that will affect the volume. Now, so we'll introduce factors that will affect the volume of that gas at that particular moment. We'll have pressure. So that means ukifinya container, what will happen? Or when the gas or the fluid inside that container touches the walls, what happens? We'll be talking about temperature. When you increase the temperature of that particular uh, fluid inside, let me say fluid for the sake of taking care of gases and liquids. So when you increase the temperature, what happens? And in those factors now gives us what you call the gas law. So we'll have what you call the Boyle's law, the Charles law, combined gas law, and now what you call the Graham's law of diffusion. We use the factors. Now, the reason why I normally introduce this is because you already know the states of matter. Now, we know that it occupies space, it has mass, and I said something that has mass most probably has volume and density. Yeah, because those things are relative. Huh? Now, when you talk about those things coming in, volume, gas, mass, and density, we must bring about the connection, which is now touching the walls, which will bring about the pressures. And now pressure is one of the physical factors that will affect the, that liquid or that fluid. And now we increase or we add other factors now, like temperature. Those are physical factors that will affect the behavior of that liquid or of that fluid. And that one brings us now to the laws now that are what we call gas laws. And that is what, so this one, that is what I was saying, everything that we are going to do is a continuation. So the major laws that we have are actually only three. We have the Boyle's law, the Charles law, the combined gas laws is, I normally say combined gas laws when I'm teaching. I normally say combined gas laws is Boyle's Charles law because we're combining the two of them. So we combine the Boyle's and the Charles law in a combined gas law. And then, of course, the Graham's law of diffusion, which diffusion, I think most of you are aware of it. So this topic actually, it is the first topic of Form 3. The first topic of Form 3. So the first two topics in Form 3 are normally very critical. I'll tell you why. Now, topic 1 is gas laws. It is a mathematical topic. The theory part is very small, but the mathematical part is quite wide. So we must take care of that one. The second topic is the mole. The mole also is quite wide, and it is a mathematical topic. So we must be very careful. So now we are going to do those steps. So this one. So in Boyle's law, Boyle's law actually is somebody's name. So Boyle's is somebody's name. So he's 1700. I don't know where we were. Robert Boyles now investigate the relationship between a volume of a dry gas. Remember, we have factors that will affect, it will affect. So there's some things that must be kept constant. We'll talk about that one opportunity. And it's pressure. So when that one, I am not going to go to the history class. We are not going to do that one. So we go directly. So it is Robert Boyles who came up with that idea. And the Boyles law says that the volume of a given mass of gas is inversely. Now, pali inaletanga shida, I'll just underline up. Inversely proportional to the pressure. So this one is the Boyle's law. This one now is the one that it is going to affect us also. So the volume of a given mass of gas is inversely proportional to the pressure applied to it. So it is the pressure that is affecting the volume here. So that one is very important. I'll write the equation up. I'll write up kando before we even go to dealing with that one or coming up with the equation. So I'll write it up kando how we can summarize the Boyle's law. So is inversely proportional to the pressure provided the temperature remains constant. So we are saying when I was introducing this topic, I said maneno ya factors that we are going to deal with, or factors zenye tunataka ku tackle, are those factors that will affect the volume of that particular gas. So we have physical factor, which is pressure and temperature. So Boyle's law alisema mimi nataka kuona pressure ikiaffect volume, lakini nisiconsider temperature. Now we'll be talking about Charles law, then you see. So actually this one is saying the volume of a gas, of a given mass of gas, a given volume. Now it is a given volume, a given mass, a specific mass. Actually that is what it means, specific. So it is a given mass. So volume is inversely. So directly proportional ningeweka directly that wrong, and then I introduce the pressure. But this one now I have to inverse, means it is over P, 1 over P. But I'll mention it somewhere. We are going to derive that equation. So there's no problem. Now, a very simple way of understanding this one is if you increase the volume, ukipeleka volume juu, inakuja chini. If I increase the pressure, let me use a different color. So if I increase the pressure, the volume will be coming. That is inversely proportional. When I talk about directly proportional, for example, kama imekuwa directly proportional, that means increase volume, pressure pia inapanda juu. But this one is inverse. So I normally like this one. I don't know, the KLB normally does not explain. Of course, KLB is a very good book, but Longhorn normally gives us this analogy of human beings. Where wanasema the number of people, or the number of, I normally like using, instead of using the number of people myself, I normally choose the number of kids. So if you have 10 kids, for example, in a family, keeping everything constant, and then there's another family that has 2 kids, and they have 5 packets or 10 packets of unga, maize flour. Kina nani watamaliza haraka, wenye wako na 10 kids ama wenye wako na 2 kids? Who do you think watamaliza mapema unga? I normally use 10 kg, but for this case, because you are watching, we are saying nani watamaliza mapema, wenye wako na 10 kids or wenye wako na 2 kids, all added. Yeah, that one is actually, yes. So that one is actually, we are saying now the pressure is the we can put the pressure, the people could be the volume. So we say the kids is the volume, and then the pressure will be the packets. So that is the analogy that we normally use. So you'll find that familia hiyo yenye kuna watu wengi itamaliza mapema. That one is actually the analogy of Boyle's law. So I don't normally do that a lot. I just want people to understand. So that one, I don't have a problem with that one. So I go now to how we derive that one. So you'll find that the family with more will complete the ratio, or the rate at which they will eat is higher than hiyo ingine. So that one is very important for you to understand. Now, so Boyle's law, we represent it this way. I'd already done that one. So before, so this one actually does not really show. So I want to show you how it came to be that it is equal. PV is equal to a constant. So we'll start from, so P, this one is the statement. This one is Boyle's law, actually, mathematically. The only thing that is missing in this statement that I've circled, or that formula that I've circled, is temperature kept what? Constant. Hiyo ndio kitu ina miss peke yake. So if I do that one, P is inversely proportional to 1 over V. So when you do that, 1 over V, no problem. So when you do that, for me to have an equal sign, this equal sign now, hapa katikati nikitaka kuleta equal sign, I remove the inverse proportionality sign, I introduce a constant. So if I remove one and I say P now is equivalent to, so I remove the wrong sign, which is normally meaning the proportionality sign. Yeah. So I'll remove the proportionality sign, introduce an equal sign, and I remove the one and I introduce what we call the constant, which is normally represented by, I don't know why constant is normally represented by K. I'm still also trying to find out. I thought it should be, students normally tell me constant, to see even can represent that one, but there's no problem. Over V. Now remember, when I value, I normally say this one because there was a time I taught my students and they were, I don't know if they were weak or they were confused. They didn't know that if a value has 1 over, for example, 1 over 4 means it is 1 over 4. They assume that this one disappears and the answer becomes 4. I don't know. I don't know how they thought of that one. I'm still also trying to figure out. So you know that, so you do not mind about this one. Huh? I'll just cancel this one because we are not talking about that today. So I cross multiply this one. Oh, you remember when something is, for example, if you have 10, it is 10 over 1. If you have 1,000, it is 1,000 over 1. So remember this one is P over 1. So you cross multiply this one, ikuje chini na huyu pia. So you'll find the P and V comes here, which is equal to a K, which is 1K. So you don't have to say 1K, you can just say K. And this one is where now that one is coming from. Ndio hii. I hope that one is okay. So if we have several volumes and pressure at that particular time, the pressure of that one. So we'll have, for example, in class A, for example, and then we have in class B, for example, class West, and then we have class East. So we'll have the pressure at East, which is, let me use E, will be different. So the volume again, because the pressure and the volume are affecting each other directly. And the pressure and the volume at E, that class E, will be equal to a certain K. Now, when you go to another class, if you go to another class, which will have a different pressure. So I had given West. So we'll have a pressure at West, hiyo class ya West. West wako na pressure tofauti. And the pressure affects the volume indirectly. So you'll have the volume at West, but zote, they are equivalent to a certain what? Constant. So that one, we can say now, juu constant, si K ni K kwa zote. So you will have PE. I normally explain using classes because because now of the different classes that we have. So I say students normally VE is equivalent to P West, pressure uko West, volume West, na zote ni equal to what? All of them are equal to a constant. Okay. Zote ni equal to constant. Okay. So instead of saying all of those ones, we normally choose numbers because numbers normally are numbers hazifiki mwisho. Yeah, it is very hard kufika mwisho kwa numbers. But east, west, north, alpha, and the rest, hizo zitafika mwisho. So we normally choose numbers instead. So instead of me saying PE, VE, I would choose now something that will be continuous because we can even go up to P10. But sasa nikitumia values, even if I use the letters, which is the alphabets zinafika mwisho, itafika Z, and I have not maybe completed the relationship. So we choose a number P1. So instead of me using PE, I'll go for P1, which is in that class. The pressure in that East class, volume in that East class is equivalent to P2, which is the pressure in that West class. V2 the volume is of, and all of these ones are the same. They add up to a constant. Now, since we are very few, I think we are two at the moment. I don't know. I think we are two. So because we are two, I want to ask kama sasa wenye tuko tumeelewa vizuri before because we are going to do an example, but I wanted to explain first. So I'll wrap this one. I was just explaining. I'll wrap those ones. And then we see. Tumeelewa. So the equation of Boyle's law will be like that, where we have initial pressure, the initial volume being the one, and then we have the final pressure and the final volume being the two. Now remember, you know what? The good thing about this one is to remember, if you increase the pressure, nataka mkumbuke pale tulisema increase pressure, volume inakuwa kidogo. Increase volume, the pressure becomes small. So that one is now summarized by this one, and I normally say the Boyle's law now is summarized. So I don't know if it is just below. Let me check. So we normally summarize the Boyle's law as so it is not there. I'll just have to write. So the summary of Boyle's law is this. Normally I choose. I think I like blue. I don't know what you like. So the Boyle's law is summarized by this. This one is something that we are going to use in the summary of calculations or doing sums, is that one. So we'll be using this one. Always that is in Boyle's law. So this one now summarizes our Boyle's law. Tumeelewa mpaka hapa? Sijui kama tumeelewa. So that I continue.
Yes.
So tuko sawa. Now we'll do
Yeah.
an example. Yes, so we'll do an example. So if you are to plot a graph, of pressure against volume, tulisema they are inversely proportional. That means if you increase the pressure, now I will do that one so that I don't do it somewhere else. So if I increase the pressure, this one means pressure hapa ni the highest. Si hapa ni zero. Let me just do it. Zero. Hapa ni zero. For example, and I say this one is 100 pascals. I'll give the units of pressure. I think it is somewhere. This one is 100. So at 100, you find that the volume is the least. It could be 5. Now, when the volume is maximum, I'll give another one. Let us say 200. For example. At that time, ukichora hivi venye tuko nachora tu ya source, we are doing the same thing. You just have to unachorea hivi na hivi. So when you do that, ikuje huku, the temperature will be maybe 10. So you find that the pressure, when the pressure is very high, the volume is very. I normally like using different colors. So, but let me just do this again. So you find this when the pressure is very high, which is this one. Ukikuja chini, the volume will be very low. When you have very high volumes, the pressure will be very low. So it is actually that way. So it will be when you plot a graph of pressure. I don't know if we have an example that has a, but I think we will get one. If you have one that we can do a graph, because I normally say when we practice more on graphs, we are affecting something else also. So when you do the graph, it will be something like that. Now, if I was to do another graph where I make this one of them to be inverse, it will be a different story. Which I think it is better when it is done practically. So that is the Boyle's law graph. Actually, Indo graph, yeah, Boyle's law enye ina obey Boyle's law. Ama yenye ina state Boyle's law very well. Now, when you change, so this one, it is the same thing that we have done. So we have P1, V1. So and then we have P2, V2, and then you see it will be changing. So that one we have explained. It is the same thing we are explaining using the other one. So we have P2, V2. We have P1, V1. Where now when you give a relationship, it will give us what we are looking for. We will see. Now, so what happens to the volume of the gas if the pressure is increased? And I think, so Mauro, you'll say, what happens to the volume if you increase the pressure? And then Wendo will do if we decrease. I think we can do that because we are only two, so it will be very easy for us to. What will happen if we go with increasing, which is Mauro?
When we
What
increase
happens?
pressure, volume decreases.
Yeah. So what do you talk about? What about yours, Wendo? Because I think it's only us, so we can just be answering.
When pressure is decreased, the volume is increased.
Yeah. So actually that one is a summary of Boyle's law. Inaishia tu hapo. We finish it there. Now, so the same, of course, when you do that, what happens to the pressure if of the gas if the volume is increased? So that one, there's no problem. I think now the graph that I was talking about, I remember I told you, if I leave the way it is, like where we were saying, remember, actually this law is saying pale tulikuwa tunaanzia tulisema P is inversely proportional to 1 over V. Sivyo ndo tulisema huko juu. Now, if I was to plot the graph of P against 1 over V, the story will change. It will be something different. So it will be something different. And the graph now, or if you do the opposite, that is V against 1 over P, if you do that one again, the pressure, this graph where you are saying V against this and P against this, the pressure will be different from when you draw V and P. And the pressure and the graph will look like this. So the graph will look like this. It will be a graph that cuts through or that goes through the origin. That goes through the origin. I hope I have a question. Up before. So the graph will look like this now. And because the other one has been, it is inverse. Because the other one is inverse. So I think we'll do a graph so that we see. I know now you're good with graphs. So I think we can do one before we end this lesson for today. We just try one so that you see. Hopefully I have one. I hope we are okay to that place. So graph drawing in this one will mean you have to make sure that all the units are correct. You are following the rules of the graph that we did previously. Ile tulikuwa tunasema make sure the scale is good so that it can cover 3/4 of the page. It is the same rules now applying in this graph. I hope that one is okay. So what you are saying uko juu, where you are saying when you increase the pressure, the volume is reduced. It is normally summarized in this diagram where the big P means high pressure, the small v means small pressure. Ukiendelea kureduce ikue, so that's such that the small p now, this P is small pressure na hii ikue high volume. These are very simple terms. Ikue pressure kidogo and then ikue volume kubwa means high volume or a larger volume. It is represented that way. I hope iko sawa mpaka hapo. I didn't want to dwell so much on explanation, but the graph is very important. So a graph of P against V moves in the opposite direction. That means it starts from this place, coming this way. But a graph of P against 1 over V or V against 1 over P will be a graph that cuts through the origin. This one now. Lakini hiyo ingine inakuja hivi. So it is very important to remember that one. Look, I think we can do an example now. So P1, V1 is equal to P2, V2. That one is very important. Don't forget that one. Now, maybe something that it has not been mentioned is maybe the units of pressure. So we have the units of pressure, standard unit of pressure, the SI units, the one that we use universally or in the universal world, kila mtu anatumia is Pascal. Now, but the other units, but they are always equal. So 1 Pascal is equal to 1 Newton per meter. So anytime you see Pascal, it means pressure. You see Newton per meter square, it means pressure. Actually, pressure is defined as force acting per unit area, perpendicular. So there is no problem. So we have another one is normally atmosphere. So ukiona atmosphere pia, I'm giving you all the names. I'm giving you all the names that we use. So ukiona atmosphere, we are talking about pressure. 1 atmosphere, you will be told 2 atmospheres, which is normally this one is calculated. For those who are doing physics, E is normally calculated. It is normally achieved, calculated. You calculate and then you achieve it. So I'm not going to talk about that one in this session. So 1 atmosphere is normally 101,325 newtons per meters square. So anytime, what I'm interested in is, let me just underline, anytime you see these, it means you're talking about pressure. So ukiona millimeter mercury, that is pressure. Ukiona Pascal, we are talking about pressure. If you see newtons per meter square, it means pressure. Ukiona atmosphere, it means pressure. So all those are units for measuring pressure. Now, we know the units of measuring volume, but let me just mention them. Anytime you see these units now, and we are talking about volume, now, it is very important for you to know, nyumbani unatumia, what is the units that you use to measure volume nyumbani? Let us just give the units of volume. We just name them. So units of volume, 1 window, you can just mention any.
Centimeter cubed.
Yeah, centimeter cubed.
Meter cubed.
Meter cubed, okay. Which other one do you think is very common at home? For example, ukiendea mafuta unatumia
Liters.
Yes. Liters. Actually, students, normally we don't forget. Most of the students, I don't know what happens when it comes to liters. Ni kama tumefunza sana centimeters cube na meter cube, mpaka watu wanasahau ati liters actually ni volume. So unaandikia mtu liters, anainua mkono anasema what is hakuna volume. So I don't know if it is, but the volume is liters is the one that we normally use. We normally use at home. A lot of times we are using volume or we are measuring volume at home. We use liters. Hata unaambia mtu muendee maziwa kwa kina nani wakupe 5 liters. We don't say akupe 5,000 centimeters cube. Yeah, I don't know. So it is liters, milliliters, which other one? Centiliters, but we don't use those ones some a lot. We use actual milliliters, especially dawa ya mtoto wanasema peana, mnaambiwa peana, daktari anakuandikia give out to, yeah. So those ones are 2.5 ml or something. So those ones are the units. So anytime you see units of volume, it is centimeters. Yenye iko na 3 juu is volume. Yenye iko na 2 is normally area. So ukiona centimeters cube, we jua ni or something is actually a centimeter square is area, but we normally categorize that one because I'm saying the definition of pressure is it is the force. Units of force is Newton. So it is the force acting perpendicularly per unit area. So this one is where the square comes in, and then we have the Newton. So it is force over area. That is why we have newtons per meter square. Anyway, so the units of pressure in Ming, we have Pascal, which is the universal used. We have the newtons per meter square, which is the same thing. We have the atmosphere. Atmosphere, atmosphere sana inatumikanga kwa, inaitwa aje hizi vitu, kwa airport you will say the pressure is 2.5 atmospheres, they know how it is converted, so you convert, alafu na weather stations they use atmosphere mara mingi or Pascal, which is the same thing. And then of course now in chemistry most of the time we'll be using millimeter mercury or centimeter mercury or meter mercury, so there is no problem. That one is very important. Remember, it is just about units. Now applications, how do we apply this one? How do we calculate? Applications is actually, it is not actually how do you, what is the applications of this one? I'm saying applications is calculations. How do you calculate? Example number one. So I think I'll do one, and then I'll give you one. You try. We see kama tumeelewa. I do one, and then we go to the next one. Iko sawa? So application number one, which is a question. So if 6 centimeters cube of oxygen is compressed from 20 atmospheres pressure, so the good thing about chemistry is they guide you. They will tell you, the only thing they have not mentioned is maybe 60 centimeters volume of oxygen. So, but you will know, due to tumesema hapo juu, the units will guide you. Always the units. Just check the units first. Don't be in a rush to answer the question without knowing the units. So it's compressed from 20 atmospheres pressure to 40 atmospheres pressure. What is the new volume of the gas? And then remember the Boyle's law we are saying. So you, hata wakikuuliza hii law ni gani, you will know because they have said what? At a constant temperature. So we say Boyle's law states that the volume of a gas, a fixed mass of gas, is inversely proportional. So I will write for you hapo chini before we go to the next law. The how we normally represent Boyle's law, kama uko in a rush in an exam. So we say it is inversely proportional to the pressure, temperature kept constant. So provided the temperature is kept constant. So hapa imekupea already, unajua. So this one, if you are asked to say what law it is, even before we continue, kama the next question will be, the first question hapa will be, which law are we talking about? It will be Boyle's law because they have said it is at a constant temperature. So that means you know how to say that one. Now, so the first solution, in the solution you identify the variables. Make sure you know what is this. Nini ndio hii? What is the P1? So you identify P1. So let me wrap that one first of all. So you identify P1, you get the V2 or V1. So we have P1. So if 60, so that one means it is volume 1. So it is volume 1. So V1 is 60. We have 20 atmospheres, means it is at that particular temperature, pressure, where we have this volume. So if we do what we call now doubling the pressure, we'll talk about that one when we talk about doubling, tripling the pressure. So if we double the pressure to this one, which now makes that one pressure to what will be the, so we don't have V2. So the first thing after identifying, you go to the formula, which is P1 V1. I'm just writing, but we'll have it down there, is equal to P2 V2. Yes. So you just place, so pali hiyo ingine iko unaweka. There is something I normally insist. Let me just wrap this one and then we go, alafu nawaonyesha what I normally insist. So that you don't get lost anywhere. So let me cancel that. So you come here. So you can do this. Now I normally do this. You can start with, you can do P1 V1 is equal to P2, or you can make the one that you're looking for the subject of the formula. Yeah, that one is normally in mathematics. Where you make now the one that you're looking for be the subject of the formula, so that will not feed to the other one. But also you can use this one, which is, I normally think if you're in a rush, making this on the subject of the formula could be hard. So to me, I normally advise students to use that one. Now, hii inasema what we are doing is, where we have P1, unaweka. So we have 20. I normally insist in writing. Please write the units. Multiply by, so let me just put times. The V1 was 60. I want you to see, even the question, the example we have done what? We have written the unit. There is a reason I insist on people writing the units. I normally insisted, Sana, please write the E is equivalent to P2. Do you have pressure too? Yeah, we do. 40 atmospheres. Please write the andika too. Imagine it will not cost you anything. And it doesn't even, I don't think you will use even 10 seconds to write ATM. Yeah, or centimeters cube. It can't check. Multiply by V2, which we do not know now. That is the one that we are looking for. And then you divide by 40 atmospheres on this side. So I insist on writing. The reason why I want people to write that one is so that you see what remains. 40 atmospheres over 40. I normally say it is better even to move slowly, lakini watu wasipotee. I told my students, I don't know, I'm better off if I don't complete the syllabus. I remain with a topic, one topic. You lose the mark for that topic, which I don't know, it could not be much. Than completing the syllabus, all of it. But from all the topics that we completed, you score 0. So I don't normally advocate for that. So inaenda. I want you to see this atmosphere. So I'll cancel this atmosphere and this atmosphere. And then this one by 21, by 22. So the only units that are remaining is centimeters cube. So the answer, whatever the answer I get is in centimeter cube. So you already have the unit. So you halfway. The answer is correct when you say 30 centimeters cube. The answer is halfway correct if you say 30. Because is it 30 cows? Is it 30 dogs? We don't know. But because we're talking about volume, you must always have it. That is why I insist on writing. Please write the units always. And the units are you already been given. So just do the writing. Sijui kama tuko sawa?
Yes.
Okay. Yes. I want you to do one for me so that we see before we go to something else. So the next one I think is for you. I'll give you a few minutes. 2, 3. Depending. Hope you have a calculator. This one it becomes very tricky. Now let us try this one. So you can try this one. Can I give you a chance to try this one? Only a few minutes, maybe 3. Let me give you 3 minutes or 4 minutes. We try. It is okay. Oh, window.
Yes.
Yes.
Example 2, teacher.
Yes, we tujaribu example 2. Now you try and then you give me the answer and then we solve together again. Siko sawa? Yeah, I'm just giving you a few minutes. So the example of gas in a balloon has a volume of 200 centimeters given a pressure of 6 atmospheres is compressed and its mean pressure increased to 20. Yeah. Let's solve that one. I think there's somebody else who is in. Yeah. Yeah, Monica, welcome, Monica. So let us try that example 2. I'm still giving those ones a few minutes so that I am seeing Wenda has given the answer. I don't know if the others have gotten the answer. Yeah, I'm seeing somebody else has chatted. Yeah, I like this class because we are normally interested. It's either we get different answers. So I've gotten, and I'm waiting for Monica. I don't know if Monica has been in, but I think she was in when we were doing the example. So most probably she could be having an idea. So I have two answers, two different answers. I have 60 centimeters cubed and I have 20 centimeters cubed. I think we can handle that one. That is why I normally say it is better to get at least uh 2/3 of the class to give an answer so that you see how they are solved, and then you can explain. It becomes very easy. So I have two answers. I don't know if Monica, can you continue so that I don't lock you out? Can I continue or I wait for your answer?
Teacher, just continue. I'm held up kidogo but nikimaliza I'll join. Nasikiza tu. Nashikika tu
Oh,
kidogo.
no problem. Yeah, then it is good. That it is good. Yeah, it is okay. Now, so I have two answers from Wendo, and so kila mtu anajua answer yake. So Wendo, you gave me 60 centimeters cubed, and then Maura has given 20. Yes. Now let us go and see this question. So nimesema hii swali is normally very easy. So you have been given a sample of a gas in a balloon as a volume. So we have already. So the first thing is you identify everything that has been given the question. Identify. So number one, you have volume 1. You identify volume 1 in ngapi? It is 2. So I'm saying even if you are not given if you have not been given that it is a volume, let the units guide you. The units, that is why I explained the units up. It was intentional because sometimes the question will give you two variables, but the only thing they have not mentioned it is pressure. So the only thing that is guiding you at that moment is the unit. So we have volume 1 is 200, and I'm saying you can start from any. There's no problem. It is like saying 2 multiplied by 20 and 20 multiplied by 2. It always gives the same answer. So you have 200 centimeters cube. And then we have and a pressure. So we have P1. So at that volume, the pressure is equal to 6 atmospheres. Remember, we were dealing with atmospheres. So, and then N is compressed and its new pressure increased too. So we have P2. So P2 now tumepewa ni 20 atmospheres. So I was just identifying. I'll go to the question directly. So what are we looking for? What will be its new volume? So what will be the volume 2? Ningapi? That one is what we are looking for. So you identify the variables. It is very important for you to know the variables, each variables, which I have identified. I was just identifying. So after that one now, you have identified. So we know which is P1. We know which is V1. We have P2. So after you are done with that, you have identified P1, V1, P2, V2, and then now you go to where you have the equation of Boyle's law. You just place there. So where you have over 20. Now, so P1, V1. So we have P1, 20, which is 6. Let me just write. So we have 6 multiplied by 200 is equivalent to 20 multiplied by V2, which we do not know. So let me just write. Somebody will tell me what happened. It's either they don't have, maybe, so it is 6. So let me write very fast due to time. I don't want to, 200. So we'll do another example. Is equivalent to 20 multiplied by V2. I'm just explaining so that it takes care of what is here. So over 20 over 20. So that hour naenda. So by 21 by 20, 10. So that we have this one. So the new volume will be 60 centimeters cube. Now we had two answers. So Maura, I think it was Maura who gave us 20. I want you to check where you made a mistake. Identify your mistake, and then you see if you can tell me so that I can correct it, or if you can correct it, the better by yourself. Unaweza?
Ndio najaribu nini.
So can I give you a minute, or let me give you a minute to try uone tu pali kulikuwa na shida, because now it is better for us to understand this one, but we are doing another example. I want you to correct the error here so that you will do now the third example. You see if you can again, so that and I hope you did a good job, so you got the correct answer. Now, but I know Mauro could have. The only problem is maybe there is an error made somewhere. I hope it was also the calculator error, where I know there is a way we normally tunaekanga calculator. I'll explain that one before we go to the next question. But in the meantime, just confirm. Now, as Mauro is confirming, as she's confirming, hope because you already know window. I want us because you've already handled it correctly. Can we try example number 3? You try example number 3. Mwaura, ukimaliza kupata era yako unaniambia umepata ilikuwa hapa, so that I can see if it is the calculator error.
Teacher, nimeona nilikuwa nimefanya tu the same 200 times 6 times 20 but I cancelled wrongly.
Yes. So now I'm saying that one is a very dangerous error. Unaona venye error venye inakuja, those are very dangerous. Another error that could have come, I assumed the error that could have come if you're using a calculator is, let me show you what normally happens in a calculator. I want you to try using a calculator this way. You say 6 multiplied by 200. It normally gives a different answer most of the times. Divide. When you do this, it could give you a different answer. So what I normally advise is, if you are deciding to do it directly, you open the bracket for calculator, and then you close the bracket, and then you divide. Then you get an answer. That means you are dividing 6 multiplied by 200 divided by that whole value yenye utapata hapo. But if you do that one, it will divide something different. It will give you a different answer mara mingi. So calculators, again, you must take care when you're using them. We are solving example number 3. Tukielewa hiyo, we are done. We go to now to something else. we are still solving example number 3, yes? I hope you are.
Yes.
Yeah, let us just complete it. You have time. I give you some 2 minutes. I just want people to understand this. But I'm still going to solve it. I want to know if you understand it. So you solve, I solve. We solve, when I solve, we also solve together. So we have one answer. I don't know, Hope, are we referring on? Window? I don't know we are referring on. So that we can solve together, all of us. But the most important thing is to understand. Now, to be able to identify the variables, that is number one. Now, to use, you use those variables to know which one is pressure. That is, you use the units to know which one is pressure, which one is. So you can solve that one. I hope she will just post it. When are we okay? Can I continue so that I don't lock anyone out? I don't want to make people. I don't know if she's in, but we can continue in the meantime. So this one, you just identify pressure 1, volume 1. So this one now is a different question. It's not like the other one. So the other one we have been doing, looking for volumes. Now, sometimes the question will ask you, give the answer in, for example, in SI units, or we can say in liters, so it is very important, of course, to know also the relationship between a liter and a meter cube, the relationship between centimeters cube and meter cube. So it is very important for you to know that, because sometimes the question will be tricky, or they want to check that you know what you are doing. So we can continue. So you just identify, after identifying and you know which one is missing, the formula comes in. So you just bring about the formula and then you factor in that one. So P1 V1 is equal to P2 V2. After that, you make the one that is subject to the formula. So we have the answer to be, I think that one was okay. So we have the answer to be 50,000 Pascal. Now, sometimes they will ask you to give your answer in, for example, in Newton per meter square. So it is very important, but I don't think that one is not something that is easy in chemistry to be asked. So those ones are things that they are not really asked. So those ones are very important. These one are some of the questions that you can try. I don't know, you can take a picture or so, and then you can try it before we go to another law. I'll still also take a picture I still take a picture. So let me take a picture and then I will share with the group. Then I'll share with the group. So then I'll share with the group. So sorry about that. Somebody was using my phone. So let me take a picture. And then this one can be the assignment that you can try. Yeah, let me just share it directly before I forget. So, and then we can start that differently. And I hope everybody have understood. I'll share this one. I've shared with the group. So we'll try that one later on. Just know that it is there for the sake. Okay, so tuko sawa mpaka hapo. In fact, let us do even one and then we just go. We go to Charles Law. So let us try this one. I'm going to choose one in question number 6 and then we answer it. Upper. So complete the following table. This one is number 6, Number 6. Complete the following table. We have the initial pressure, initial volume, and then you have the final volume, and then you are told what will be the final pressure. So we have everything. So what you do, let me just do this one. I'll do this one very quick too. So we put P1, V1. This one is how you will be solving this one. You solve it somewhere before you come and write. P1, V1 is equal to P2, V2. So P1 is this one. So unaweka 760. So mine I will not add the units, but it is very important for you to add the units. Because then you multiply by 300, which is centimeters cubed. 300 is equivalent to, we don't know pressure, the final pressure, which is P2. So P2, you multiply by 5,000. So I will solve this one so that people can know how to solve there. So over 5,000. And then this one also is over 5,000. That is how you are going to solve yours now. And then you, after solving, you know the answer. So huyu na huyu wanatoka. So this zero, the two zeros, I think the two zeros would go huyu na hii. This 300, huyu na huyu, this one and this one. So you have 76. I have to solve mine. Let me just solve mine because this one is mine, so that I can write my answer. So it is 76. 76 divided by 3, 228 divided by 5. Mine is, so the final pressure, yeah. So P2 is equivalent to 45. Is equal to 45. So you must use your calculator for this, because you get a decimal. 45.6 millimeter mercury. So mine, the answer for this one is 45. We only use the formula 0.6. And then you maintain now the units that you are using up, where it is millimeter. Mercury. So I think you can solve the rest. So I have solved number 1. So I have to rub now. So nikimaliza hapo, this one actually was not giving us a chance of showing. They are saying only complete the table. So the table, you use the formula still, but the answer is the only thing that is written there. So I'll rub this one, and then I have my answer left there. So the answer is 45.6 millimeter mercury. So that's how you're going to solve those ones. So this one is just something that you're going to practice on. It is more practice. So you can do that. That one is very important. I hope kila mtu ako sawa up to that place. That one is only for Boy's law. Boy's law gives a relationship. So I had said before I leave, I'm going to give you the summary of how to you. Ukisahau ilikuwa inaendaje ukiwa exam room, you're in an exam room na kimeumana, you just have to do this. Boy's law, the volume is inversely proportional. The volume is inversely proportional to the pressure. sindio? So VIP, the volume is inversely proportional to pressure provided T is kept constant. So ukishajua VIP, T is somewhere silent, it is kept constant. That one is Boyle's law. The volume of a given mass of gas is inversely proportional to the pressure. So the P takes care of proportionality, but that one actually is not really important. Inverse proportional. The problem that comes in is quoting this one as directly proportional. If you quote this one as directly proportional, it will change actually how that formula will be shown. I hope iko sawa. So Boyle's law is VIP, B VIP. VIP. So it is very important to say it is VIP. Volume is inversely proportional to the pressure. T is kept constant. Now, this one is very easy. You will not forget when you are in an exam room. Ukiingia tu unaandika B VIP, then you just now have to put in the words. So that one is normally how we normally state it, so that you don't forget. And if you have a different formula, don't use mine. Yeah. So you don't have to use mine. Now we can continue. So you will try those ones. So we go now to another law. So nilisema we have these laws, the three laws that we're going to study. Nilisema one of them is combining the two, Boyle's and the Charles law. So we don't really talk about that one, but we have to do a calculation on that one. And there is no combined gas laws stating or statement. There's no stating of the combined gas law, as in we are saying the volume and the temperature being given, or the pressure and the volume being talked about or being compared. Yeah. What is happening here, or the in combined gas laws, we are combining the Boyle's and the Charles law. So that one is very important. So we are done with combining volume and pressure. Remember, we had talked about when we started this topic to Lisema, we are talking about factors affecting gas, which is the physical factor. So one of the physical factor was pressure. Na tumemaliza volume affecting, or volume being affected by pressure, or vice versa, which is true. So we have volume affecting pressure and pressure affecting volume. So that is the vice versa. Now, what about now when we introduce temperature affecting volume? We had Charles' law now brings in that idea of temperature affecting volume and vice versa. But now what is kept constant now is the other physical factor, which is pressure. So we have this scientist, which was Charles. I don't know how Wazungu normally calls themselves, Charles. Actually, Jacques, you can say Jacques or Jacques. Charles was, I don't know, now the family name or something is Charles. So investigated the pressure relationship. Of course, it investigated the relationship between a volume. So it is a relationship between volume and temperature. So remember, Boyle's Robert alisema wacha nione relationship between volume na pressure. Charles alikuja akasema wacha pia mimi nione volume and temperature. That is one. And of course, now this one is something. That is why I was saying all these laws are people. They are owned by people. So ni ya watu. So it says that at a constant, remember that we must keep something. So you can start with that one, or you can start with this one. The volume of a fixed mass of gas is directly. So we are changing now this one. It is no longer inverse. It is directly proportional. So we have the volume of a fixed mass of gas is directly proportional to its absolute temperature, provided the pressure is kept what? So we are keeping this one constant. This time, I'm repeating the way I stated the first one so that people cannot forget. I'm also underlining the word or circling the word absolute temperature or absolute so that people can understand. Now, absolute temperature is measured with respect to the absolute zero. Now, absolute zero, I had mentioned it somewhere in what do you call acid, bases, and source. We talked about absolute zero. Mnakumbuka pale tusema absolute zero, which we had explained. Absolute zero, actually, we normally refer it to something called the Kelvin. We do not talk about the temperature in degrees Celsius. Wacha nirudie hiyo polepole. Tukifanya calculations, or when you're doing something with this one in Charles' law, or in the combined gas laws, because they will be doing calculations, an example. When we are in combined gas laws and the Charles law, the temperature should always be in Kelvin. Shika hiyo kabisa na ushike vizuri. All the calculations, the temperature will be in Kelvin. Yeah, because of the absolute zero. And absolute zero, actually, I had mentioned that is the lowest temperature where the volume of a gas is assumed to be zero. And we did it in the other one. When you're talking about the, I think we talked about it when you're in acid, bases, and source. It is the same absolute zero. So nothing has changed. Now, if I was to give a relationship now, the way we did the first one, the relationship of this one is volume is directly proportional to the pressure, the temperature, not the pressure. I don't know why I'm bringing in the provided pressure is constant. So this one is constant. Let me just write in for the sake of this one is constant or constant. So the volume is directly. I want you to see the difference between inverse and direct. Hii sijaweka 1/t, nimeweka v directly proportional to t. Hivyo. Now, if I wanted to remove this wrong, which is now nimesema the proportionality value representation, it is v is equivalent to k, where k now is our constant, t. But we want to make t k the subject of the formula. So I divide by t, this is over t over t. So huyu na huyu wanatoka. So the k is equivalent to constant v over t. So if we are in many classes, I use classes, we have the temperature of East being 200. The volume in East will be different, but it will be equivalent to the constant. The volume at West in a different class, and the temperature in that class is different. All of them adds up to what? A constant. So we'll have VE over TE equal to V West over T West. And remember, the temperature is in Kelvin scale. Hiyo ni ya kwanza. Ya pili, the pressure is kept constant. From now the definition of Charles' law, or the stating of Charles' law. So because, and all of these one, ikiwa east, west, zote zina add up to constant. I repeat, because east and west inafika mwisho, or when we use the values, which is the alphabet A, B, C, D, itafika mwisho, which is only 26. We can be dealing with values that are reaching a trillion. So we choose numbers rather than that one. So instead of VE, I can use V1 over T1 is equivalent to V2, and this one can continue over T2, which is also equal to V3. When the two, you can continue mpaka V trillion over T trillion, yeah, over T3, and all of these ones, kila kitu, that relationship is always equal to what? Okay. And this one now, we normally choose only the first two because of our sake, because of the calculation. So V1 T1 is equal to V2 T2, which is equal to a constant. And this one now is what we call the Charles equation of Charles law, or the Charles equation. Iko sawa. Iko sawa mpaka hapo. So whatever I have done here will be repeated hapo chini. But I wanted you to understand, first of all, have you understood before I continue? I'm rubbing because I want to move to the next thing. I wanted us to remember. I want you to remember something. The temperature. Tafadhali msisahau temperature equal in Kelvin. We will see how that one is converted before we go to calculations. I will show you how that one is converted. I can even use simpler notes. Hopefully, I'll go and then we can see. Now, so they normally use the same analogy. Directly proportional means we have maneno ya chapati. I don't know if your favorite. I think the time taken to finish eating, I give a number of chapati. So that one. So we can say if we have 32 or 20 chapatis, and then we have 5 chapatis, which one will take a shorter time? That is directional proportionality. The more, what you're saying is, ikiwa mingi inachukua time mingi, ikiwa kidogo you use a very shorter time to complete, and we can use that one. So I don't want to use the analogy at the moment because now, figuratively or in a figure form, when you represent this one in a diagram, small volume, small temperature. This one is figuratively, yani ni ukweli. A smaller amount of volume is directly proportional to a smaller amount of temperature. As you increase the volume, the temperature, of course, or if you increase the temperature, the volume will what? Increase. If you increase the volume, the temperature will increase. Actually, this one V, figuratively the bigger the V, that is the higher the volume. The smaller the V, the smaller the volume. The bigger the T, the higher the temperature. The smaller the T, the lower the temperature. Yes? Yes. So it is explained this way. Volume increases, temperature also increases. That is basically what we are talking about there. So that one is the representation, is a constant. So if we do that one, we have V1 now is the initial volume, T1 is the initial temperature, V2 is the final temperature, and then now final volume, and T2 is the final temperature. That one. So if you plot a graph, this one now is where it gets interesting. I wish I have a graph of this one, so that before Mwaura you submit the other one, you can submit with this one. I will look for a question that will have this one. So if you do a graph of volume against our temperature, the graph will look like this. And this one is very important for me to explain. The graph will be, it has a positive gradient, but it doesn't pass through the origin, but it will cut the x-axis at negative 273 degrees Celsius. Actually, ukichora inatokea hivyo. Even if you do a practical, it will come this way. I hope I have a synthesis practical that is an online one where it has been done by a computer. Or if I can give you a site, it is normally called there's a name that you can go and check. Unaweka volume, unasema unataka volume equal 10, what will be the temperature? And then you do that. No, I think the name will come. I normally use it most of the time. It will give you this graph. Now, this graph, upper they normally ask, what is the significance of this? This one actually is what you call the absolute zero. The zero, absolute zero. Where now at this point, we normally say we are assuming that the volume of that gas or of that particular gas is zero, and that particular fluid is zero. So that one is normally absolute zero. So it has a significance. This graph is normal. If you draw it in aenda even, if you draw now the different one, it will be a different graph altogether. I hope we are together mpaka hapo. I hope people are understanding. Yeah. So we have the volume at 0 degrees Celsius for each substance. I'm not going to explain that one. So we are saying if the gas does not liquefy, as happens to gases at low pressure. So this wachana, I don't want to explain those ones. I wanted only to tell you the importance of that thing. Yeah. So this temperature at which theoretically a gas would have no volume is not as absolute 0. Because so I wanted only to tell you that this temperature, I want you to see the temperature is in degrees Celsius. They have used degrees Celsius, but absolute 0 is in Kelvin. So it is negative 273 degrees Celsius, which is equal to 0 Kelvin. We'll talk about that one, uko chini. So we'll talk about that one. Now, when we want to convert, because we must convert, but I think this one also is normally done. If we want to convert degrees Celsius to Kelvin, we add 273. For example, let me just show you this one. Negative 273 degrees. This one is negative 273. Hizi vitu zingine zenye nimeskip, this one hizi hapa mpaka hapa. It is just an explanation, but the most important part is absolute 0. I hope you are not minding me skipping those ones because I want you to understand something. So we have negative 273 degrees Celsius so that you understand why this one is called absolute 0. So we are saying when you are converting Kelvin from degrees Celsius to Kelvin, we add, this one is degrees Celsius, so we are adding what? 270. So when you add plus 273 hapa inakuwa ngapi? Plus 273 inakuwa ngapi? 0. Now the 0 is K, is 0 Kelvin. That is why now it is called absolute 0. Na tulikuwa tumedefine absolute 0 huko tukasema hapa ni pale tuna assume volume ya gas ni 0 or volume of that fluid at that particular place is 0. So when you're adding, when you're converting from degrees Celsius to Kelvin, you add. That one is very important. Sijui hata kama napaswa kuwaambia the opposite. I mean, when you're coming from Kelvin to Kelvin to degrees Celsius, I don't know if I'm supposed to confuse you ama niwaachie hapo at the moment because you are interested in converting from degrees Celsius to Kelvin. We are not actually interested in bringing it back unless the question insists that you convert. So if the question insists that you convert it, I'll still tell you. So they have given us an example, convert 25 degrees Celsius to Kelvin. That is what you do. You just add 273. Now, before we go to application, so this one is giving us only that part of conversion. Now, I want to use the same example to show you how to convert it from Kelvin. So let me just do this drawing up. So if I wanted from Kelvin here to changing that one to from Kelvin to degrees Celsius, I want to use the same example. You have been given 298 Kelvin. So what you do is the 298, okay, sorry, 298 K, you minus, it is 298 Kelvin minus 273. I want you to see how this one is done. You know, maneno ya minusing inaletanga issues. Now, when you add, there's no problem. What is now, let me just ask you. You are free to answer this one. 273 plus 25 ni ngapi? 298. What is 25 plus 273? Does it change? 25 plus 273. Does it change the answer? So the answer still remains 298. Now, when you add on this other side, if you mess up and convert it in a different way, or by mistake, usahau useme ni 273 minus 298, it will give you a different answer. So it is very important for you to understand that it is the Kelvin minus 273. Hata ukipewa 203 Kelvin, you minus 273. It is not 273 minus the value that you have been given. I'm saying when you're adding, there is no problem. When you're minusing, it becomes problem. Inakuwa shida mingi. So that is why you have 0 Kelvin. For example, the one that we're using in the graph, 0 Kelvin, you say minus 273. 0 minus 273, we only remain with that one because 0 does not affect. So it will be negative 273 degrees Celsius, which is also the same as the absolute 0. Up. I hope tuko sawa. I hope you're okay. So when we are converting, you add. That is from degrees Celsius to Kelvin. You add 273, which I'm saying, maneno ya addition, there is no problem. You can add from either direction. It is not affecting anything. You can say plus 273 plus 25 or 25 plus 273. There is no effect. The problem comes in when you are converting from Kelvin to degrees Celsius. You are supposed to say it is the Kelvin temperature minus 273. So after you pay with 0 Kelvin, you minus. It is not 273 minus 0. Very important. That one is very important. Yeah, I just had to mention that one before we do the applications. So Charles' law says that before even I go to the application, just a summary. So we are saying Charles' law, the volume is directly proportional to the temperature. So CV dt. Now, for those who know about vehicles, I'm a vehicle fanatic. So CVT, I normally say we have this gearbox. The new gearbox, continuous variable transmission, is called CVT. So I normally say Charles' law is for CVT, CVDT. So it is Charles' law. The volume is directly proportional to the temperature, provided the. Remember, there's something that is small in the feature pahali, which is the pressure. So CVDT. I normally, so this one is Charles' law. So V1 over T1 is equal to V2 over T2, and this one, the T2, remember these ones, the temperature is in Kelvin scale. Tafadhali kama iko in degrees Celsius, which most of the question are, convert, don't calculate using degrees Celsius. Convert to Kelvin, alafu calculate sasa using this formula. So Charles' law is CVDT. Boyle's law, VIP. So remember, we are all of them, the relationship is volume, and then only we are now changing the two factors. We'll be talking something. I don't know if this one is the topic where it has a standard temperature and pressure, STP and RTP. I think this one is the same. So we'll be talking about now that one. So there is no problem. I hope you have understood all of those ones. So let us now let us apply. I wanted to say, man, temperature, it must be in Kelvin scale. But sometimes the question will tell you, give your answer in degrees Celsius, which the first question you're going to do that. Application. One example, a gas occupies a volume of 100 centimeters cubed at 27 degrees Celsius. What will be the temperature of the gas if it occupied a volume of 200 centimeters? So we are using that one. So all the temperatures in degrees must be converted. That one is the first thing. All temperatures in. The first thing ukiona tu unaona unasema temperature hapa kama iko in degrees Celsius, una convert. Hata usifikirie kwanza maneno ya Charles' law, convert kwanza ndo ukikuja sasa huko. And what you must do in this one is you must always, I hope you can still see, I just moved it. I just moved it somewhere kidogo for the sake of let me just close it first. Yeah, let me just close it. Let me not use so the first thing that you must do is to convert. You convert to so we have, so you can choose first, but the good thing is to convert. So all temperatures must be converted, so you convert them into to Kelvin scale. So for example, our case is 27 degrees Celsius. So you add, nimesema una add, you add. Don't use that idea of 0 degrees Celsius is equal to 273. What about 27? Yeah, don't use that one. It is better to, we have said when you are converting from degrees Celsius, we add. So you show, then you add. And then you identify now the variables. So which is, we have V1, 100, we have T1 now. Instead of write, you can even write 27. So what I normally advise, because sometimes students wanna, they might forget, you write up 27 degrees Celsius, and then you plus 300 Kelvin. Yeah. Or so that you don't, you know the problem is you have not been given 300. You have only been given 27. So you just have to write it 27 degrees Celsius for 300 Kelvin. Then you have V2, which we have in this case. So what will be the temperature which we are looking for? So you come now, V1 over T1 is equal to V2 over T2. So pali kuna V1, you just replace 100. Let me just replace, I'm doing this one for the sake of hiyo ingine wame, this one even is actually good. I think we can use this one instead of me writing. So we have 100 for V1 over 300K, and I want you to see the units have been written. Please don't leave out the units. Is equal to 200 over T2, and then you cross multiply. Huyu na huyu anakuja na huyu anaenda hivi. But remember, the units will be cancelled. Now after that, so ukishafika, let me just close this one first of all, and then I come back to this one. So una cross multiply. So I love to rub that one, because when you move, this one is something we are writing on top of the note. So ukisha move, you cross multiply those ones, you'll find that 200, the 200. So let me just, this 200, hizi zenye tuli multiply mbili zinakuwa pamoja, hizi zinakuwa pamoja. So you'll be having, let me just explain here, because they have just summarized. So you'll have 300 multiplied by 200. Okay, sorry. Divided by 200 is equal to 100 multiplied by T2. And then you divide now over 100 over 100. That is now where we get that one. So this one can go with the zeros. So that is where we have the 600. Okay. Now I want to convert this question this way. Give your answer in degrees Celsius. Nataka watu wanifanyie. I want you to do that one, because they are going to do, I know that question will be there, but for now, wacha tujaribu. For those ones who can, if you can, it is okay. Can you convert 600K to degrees Celsius? If you can, if you are in, that means so the final temperature is that one. So give your answer. I would have asked the question, give your answer in degrees Celsius. Can you give the answer in degrees Celsius?
It will be 327 degrees Celsius.
Yes. $327. Who else has a different answer? always a different answer. So I'm saying when we're converting from degree Celsius to Kelvin, you add the two values. And I'm saying when addition, there is no problem. The problem comes in when you're minus. So you must be very careful when you're minusing. So you have 300K. So when you're converting from Kelvin to degree Celsius, you minus 273. But it is the Kelvin minus 270, not the other way around. Not 273 minus the Kelvin. So it is 600 minus 273. That one is very important. Let us go to question number 2. The volume of a gas at 30 degrees Celsius is 400 centimeters cube. What will be its volume at 50 degrees Celsius? So I think you can try this one. Let me just give you how many minutes? 5, because time is really moving quite fast, especially when you are dealing with calculation question. Can you try this one, please? Please. So you can solve this one, eh? Tujaribu hiyo tu. I'm only giving you 5 minutes. Even 5 minutes is a lot. 3. Let me give 3. Tujaribu hiyo 3 and then I if you can speak, you can just say the answer. If you cannot, you can post it on the chat. It is okay. I'll accept it.
Mine is 430.67 centimeter cubed.
Okay, 430.67.
67 centimeter cubed.
Yes. I can see it from the wall. I don't know. I was hoping to get at least two, or we can work with one. I think it is okay because of time also. They want to
Mine is 426.4.
426.4, 430.
Yes.
426.4. Yes, it is okay. I think these are very good answers because they are very close. So the error could have been very tiny, or maybe some division or something. So we see. Let us solve this one. Yes, let us solve that one. Let us check. So the volume. So the first thing tulisema we convert. Anytime you see degree Celsius, it is not workable. Let me say it is not usable to calculate using. I don't know. That is very wrong English. You cannot. It is not workable to use degree Celsius while you are calculating. You cannot get the right answer. So it becomes very, very wrong. Okay, badilisha. So you don't change it from degree Celsius to Kelvin. So you cannot. So the first one is 303. So you add, get 303. Second one you add, of course, again you get 323. Now, after adding, you have V1, T1, you identify now the variables. You have V1, T1. So we have T2, we don't have V2. Yeah. Then we cross multiply. So we introduce now the Charles law, which is V1 over T1 is equal to V2 over T2. Therefore, these three dots means therefore 400 over 303 is equal to, then you cross multiply. So the answer is 426. I don't know. I don't know what happened with Maura's answer, but let me try also using my calculator. It could be the 23. You multiply by 400, and then you divide by 303. So the answer is 426.4. I don't know, somebody has posted something on the chat. Let me just check it very quickly.
423.40, teacher. I had calculated with 300 instead of 303.
Yes, that one is an error. Yenye ni mbaya sana. You see now you lose marks because of, I don't know what happened. I don't know. Why did you use 300? I want you to tell me why you used 300 first of all. So that we can continue.
I added the 30 plus 273 and I got 303. Now when evaluating, I used 300 instead of 303. The one I had in convert.
Okay. Yeah. You know, sometimes mtu atasema unajua nilisikia mwalimu akisema ni 270. So akaamua akate tatu aseme nilisema wana 270 273. Asema sikusikia 3 ni kama network ilikuwa mbaya. That one also is another possibility. So please you add 273 and make sure ukisha add check, please check. I think that then we are okay to go. We are okay to go to the next question. Now, state the Charles law. How do we represent it mathematically? That one is very important. If you know how to state the law, you can know how to state to represent it mathematically. Now, I don't know. I have very few minutes. Too few for me to go to the next one, which is normally the combined gas law, which is normally called the general gas equation. So that one is the next one. I think we'll start this one another time. I want to look for a question. Let me just close this one, and then we do another question. Because when we meet next, we'll do the combined gas flows where we'll have STP and RTP. I want us to add another example. So I'm sharing something different. I don't know. Let me check. First of all, somebody posted something. No. Okay. Let me check. I hope I get those as soon as possible. Don't mind, don't mind. So I hope you have understood how those things are done. So that if it is there in the exam, if you get it in the exam, you ushtuki what is going on. So it is very important to let me check if I have these questions so that you see the slots. Let us open. It is PowerPoint. I wanted to check the PowerPoint notes before. So I hope I can still share. Yeah. I can very quickly. Now I might not open the full one because of time, but I want us to see something small. So this one is PowerPoint. I'm looking for a question that we can do. So I changed. So when you're converting, this one is very important. Let me just repeat it. Kidogo. So the temperature scale. So this one now is the summarized notes. So when you're converting, Kelvin scale is equal to temperature plus 273. That one we are done with this. So there is no problem. I don't want to do that one. I'm looking for a question. Pressure law. We don't do pressure law in this class. In chemistry, we don't do pressure law. We do it in physics. Physics pressure law, but I'll mention it. I'll mention it. I'm looking for a question. I thought these are not questions. Yeah, let me just look for. This one is a summary. This is only a summary. Normally a summary of that one. Yeah. So this one is a question on Boy's law, but time is already on not on our side. We can try this one alone. If we leave the other one, then we can do it. I'll still post the questions, a few questions. So you can post your Boy's law. Let us just do this one and then we end it there. That one is okay. A gas has an initial volume of 30 meters cube at atmospheric pressure of 100. This one now is the one I was talking about. You're given kilopascals or something. So these are normally very interesting. So kilopascal, so it is very important. Calculate the final pressure of this gas if its volume is decreased to 10 meter cube. I don't know if I can leave you to try that one. Can you try this one? It's an easy one. This one is Boy's law. So we are going to P1. Let me check if I can write. We have P1. So the formula is P1, V1 is equal to P2, V2. Remember, this one you don't have a problem with the maneno conversion because the units already will be the answer will take care of those the units that you will need. For example, in pressure, you will take care, the Pascal will take care of pressure for volume. So after you have done writing that one, you identify now the variables. You have P1, V1 is equal to 30. So when we meet next, because I heard that you could be having an exam, so I'll release you early. As soon as we complete this one, we just end the topic there. That's subtopic, not the topic. We have P1 is equal to 100 kPa K. I want you to see how it is written. Nataka uone venye imeandikwa. It could be 1,000. This one could be 100,000 pascals. And then we have V2 is equal to, so you just identify the variables, 10. So you say, what is now, what is P2? alafu sasa you choose. So you just unaweka pahali hiyo iko, you put that one and then you solve it that way. So you replace V1 is 30. So ni 100. I'm saying please write the units. Mine I might not write because of time. I'll by 30.
300 kPa.
Yes. So is equal to P2. I don't know P2. So you have already answered. What is your answer?
300 kPa
Yeah,
per.
over.
Mm.
Yes. Inaitwa kilopascals. Conversion of kilos to kilogram to grams actually. So Pascal equal gram, kilogram equal, so over 10. So over 10. So this one is how you solve those ones. I wanted just to show you, but I have summarized notes. If you need also these ones, but these summarized notes now requires you to have more information. That is why I was using the wider notes. So because now we have to explain the concept very slowly. So for the concepts to be explained very slowly, for these ones, the answer is 300. So pressure 2 will be 300. Okay. PA. Remember the kilo it is like saying kilojoules. So kilojoules, the K is small, the joules is the unit, so you must show it the bigger value. Unless there is a very burning question. Unless there is a burning question. Unless there is a burning question. Unless there is a burning question for now. Can end it there. I wish you a very nice weekend. And if you have not understood the questions, or if you have not understood the two laws now that we have tackled today, there is no problem. I'm available. My number is in the group, so you can just holler at me. I'll still step in and help out. Otherwise, I wish you a very nice weekend and have a very
Teacher,
fruitful week.
me, I have one.
Yes, please
Teacher,
ask. Yes.
if I need the 2025 past papers, have they been
Yes.
released to the sites?
I don't know. I can check. The last time I checked, I think it was when you open. I checked when you opened school, but it was not yet. But I still think we can still get the papers. I'm very sure we can still get the papers. But let me confirm. When we meet next, I'll confirm to you about the papers. But I think Zico. I've not
Okay.
checked yet at the moment. Yeah, kama
Mm.
Zico, I'll still share. I'll still share. I'll still
Okay.
share. Yes, yes.
Okay, thank you. Good day.
So good day. Good day.